reason, my friend. Pay attention. The batteries are here, the motor of the anchor. The positive of the battery enter here, and from this switch I enter here. That's the distance between the battery and the motor. The signal to activate that motor is from the fly bridge. This is the fly bridge. This is the fly bridge. This is the switch on the fly bridge or in the pilot hand. It's clear, my friends? From that point, I use those small cables. With those small cables, I enter here and here. Bring the positive. That's correct? Probably that positive in the switch in the fly bridge is connected to other group of batteries, the house batteries, that positive. Yes or no? But that group of batteries and this group of batteries, the negatives are connected together. I can send that positive here or that positive here because the negatives are connected. That's correct? This is your question?
Yeah, I got it.
This is the remote switch over there. With the remote switch, I bring the signal and I close the gap in the relays that are located inside. I close this or close the other one. That's good? If this element is damaged, I can replace this element for a couple of relays. What is the procedure to connect both of them? The power enter in the middle. The power coming from the breaker, the switch. Enter in the middle. And I have one output for right side and other output for left side. How can I activate left side? With a blue signal from the fly bridge, from the console. Blue signal. Or yellow. And the ground in the middle, here in the ground bus bar. Finito. Difficult? Ground here in the middle. Blue, yellow. Exactly the same for the other one. Exactly the same for the other one. For this. I have both scenarios in this board. You have that group in front of the boat, no? For bow thruster and windlass. It's a group of batteries over there. And of course, the bow thruster and the windlass, the positive cable of the bow thruster, the positive cable of the bow thruster enter from that group of batteries over there. However, the signals, those signals are coming from the fly bridge. And normally, the power in the console of the fly bridge is from other separate group of batteries, electronic batteries or house batteries. If those batteries are not connected with the batteries in front of the boat, you can send the signal with the joystick?
Nope.
No.
So can you just run that to a negative bus bar in the helm, and then from there down the engine? So
all of them.
All bus bars? One
from the helm into the engine room. One from the helm to the house. Other one from the house into the front batteries. Other from the house to the back batteries. Other from the house to the generator batteries. Yeah? All of them connected together. Doesn't matter if you have redundancy, more cables. Mr. Lopez, you have this cable connected with the cranking battery. You don't need that one. Yeah, probably you don't need. But if you have more, it's better. Everybody follow me? Okay, pay attention. Suppose that I say to Dalton, connect pretty close to the bow thruster in front of the boat, one bilge pump. Okay? I want that that bilge pump receive the power from the house batteries. Don't use those batteries, the batteries of the bow thruster, for the bilge pump. Everybody follow me? Dalton, go over there, put the bilge pump. The positive, you run a cable from the house battery bank or from the positive bus bar of the house battery bank directly over there. No? With a breaker in the DC panel. This is the positive cable. Can I use the negative cable for the bilge pump directly from the negative bus bar close to the bow thruster batteries? Yes, because all of the negatives are connected together. You don't need to run one negative over there until this point. Only the positive. Good? Everybody follow me? Ah, Mr. Lopez, but the positive is on the panel, but the negative, no. No problem, because all the negatives are together. Other Mickey Mouse technicians, they connect the negative to the bonding system. Oh, because it's running. Yes, papi, but this is bonding. In the moment of the storm, you have millions of volts, millions of amps. What happened with that Bills pump? Explode. Kaboom. You understand? The bonding bus bar is not a negative bus bar. The bonding bus bar is a bonding bus bar. That's okay, my friends? You follow me? Let me explain something. One thing is the DC panel. The DC panel receives power, positive power, from the house battery bank. Yes or no? This is the DC panel. In the majority of the boats, in the DC panel, you have a lot of breakers. And one of the breakers in the bottom is electronics, and that breaker feeds the electronics sub-panel. And other breaker in the bottom, a.c.r, feed the console, the dash. Yeah, in some boats. To keep power in the console, in the gauge, in the instruments, you need to activate that breaker in the DC panel. And now you have power here. I go to the fly bridge for electronics. I don't have power. Oh, go to the DC panel, the main DC panel, and activate electronics breaker. And now you have power in that panel. Everybody follow me? This is the best way to wiring a boat, because you have the control in this panel of everything. Oh, I have a fire in the console. No power in the console. The DC panel is the master for the rest of the small sub-panel. Good? In the console, in the dashboard, I have other small switches for navigation lights, for lights and small instruments over there on the dashboard. How many negative bus bar can I install in my boat?
As long as they connect.
I have one in the console, other in the cabin. In the cabin, probably I have 3. The secret is all of them together. All of them together. And your boat is perfect. And at the end, all of them together and to the bonding. Because the bonding is the drain. Let me explain something. What happens if you have one Bills pump that the motor internally, the electric motor of the Bills pump have a leak? What is the meaning of that? The Bills pump is not running, but the winding is leaking current. It's suctioning from the positive and leaking into the negative. Okay, what happens if the negative bus bar is not connected to the bonding? That current is storage in the case of the pump. And the case of the pump, with that static electricity accumulated over there, surrounded by a marine environment, will be corroded easily. Finito.
Yeah, that's why it always goes to the sink. And the sink...
The sink drain.
Yeah, the sink drain.
The sink drain. The sink is the sacrificial animal.
Yeah.
Alright? That's great. Any other question about DC?
That's the relay. If it's rusty, is that okay?
The most important is that it's working. This one is not rusty, but it's not working. Let me explain why that relay is damaged. I want to explain this relay. Look, this is the input signal, and this is the output signal. How is the connection between this and this?
No.
Normally,
Closed.
normally, open.
Open.
When I bring power here, what happened with this?
Close it.
Close. How is the connection between this one and the middle one?
That one's closed.
Normally closed. When I bring power, open. This one is opposite than this. Yeah? In what cases? This one. In what cases? This is power coming from ignition. This is the signal that I want to send. And this is the signal out. Between this and this is normally open. When you bring the power, closed. And you send. Like this. Look. Look at this. Follow me quickly. In between this one and the middle one, look, the power for the coil in this moment is off. I don't have power. The signal in between this one, this is the positive bus bar, and the middle one, no power in the coil, is normally closed. If the green color is closed. When I powered the coil, what happened with that signal? Disappear. Okay. Now I have power in the coil. How is the signal between this and this?
Closed.
It's closed. When I remove the power, open. You understand? That's the best way to verify that relay. Okay. In what scenario in what case I use this connection or this connection? In what case I use that one? Give me examples.
When you push the button, you want something to turn off.
For example, when you activate ignition switch, you hear the fuel pump. You hear the power of the windows. You see the lights on the dashboard in your car. It's because when you activate ignition, when you bring power here, in this output, you feed the fuel pump, the radio elements.
Wait, in which one? The middle one or the other?
In this one. In this one. With no power in the ignition, all of those elements are off. It's clear? When you power it, all of those elements are on because you close the gap.
So,
suppose that I have 4 relays. 4 relays exactly like this. And I have the ignition switch here. This is battery, this is ignition, and this is start. Ready? Okay, the battery receives the power from the positive bus bar. Yes or no?
Yes.
This one is ignition. Okay. All of the relays, I am going to locate ground here. Ground here. Ready? And I have the computer of my car, the computer of my boat with different outputs. Okay, pay attention. Suppose that this output, when I activate ignition, suppose that here I have the fuel pump, and the fuel pump is negative, and the positive cable is 12 volts. I have the oxygen sensor, and the oxygen sensor, the positive is 3.7 volts. I have other sensor, a throttle position sensor, and the throttle position sensor needs in the positive 6.7 volts. And I have other element that this is the positive, and that element starts when you activate the ground. You need to activate that element with the ground, not with the positive. Okay, I am going to install here from the positive bus bar, I am going to bring here one positive, 12 volts. And here I need 3.7. 3.7 coming from the terminal number 12 in the computer. 3.7 volts. And I need 6.7 in this terminal of the computer. I have 6.7. Yeah? And in this terminal of the computer I have ground, and I am going to bring the ground here. When I activate the power, when I send ignition, I activate, okay, this element 3.7. I activate this element, 12 volts. That one 6.7 and that one ground. With one signal here, I send 4 different signals. 4 different signals with one signal here, 12 volts. That's clear?
Yes.
Everybody follow me?
Yeah.
Oh, this is the fuel pump. I hear, and I hear the other, the radio. I hear the lights because there are different relays per each equipment with one signal here. Those signals with different voltage are coming from the computer because the computer produces different outputs. Yes or not? Is clear the function of this of those relays? Why I need the relays? For example, in some moment you say, Mr. Lopez, when I activate ignition, I don't hear fuel pump. I don't hear fuel pump. Okay. Number one, what is the procedure to verify that?
Check the battery.
No, before of that.
The battery.
Yeah, after the battery. Go into the pump with 2 alligator cable, positive and negative, feed the pump. Oh, it's running, Mr. Lopez. Okay, the pump is good. Okay, we are going to check with this element. We are going to check with this element. Look at this. I connect to my ground bus bar, negative bus bar, and this one. And now I activate ignition. And I punch this cable. This cable. I don't have power. I don't have power.
Not relay.
Let me go to the relay. In the input of the relay, yes, I have power. In the output with I select ignition, no power.
But you still gotta confirm.
Finito, I replace the relay. That's clear? In the input, yes. On, nothing. Let me jump at this cable. Oh, I have pump. Okay, this is damaged, the relay. I need to replace the relay.
What do you use?